Hey guys, so in this video, I want to go over the basic math skills that you need for trigonometry class. And this is the bare minimum, remind you. So let's go over it. I will post this on Canvas. Please try to do it yourself first. And then if you need help, come and watch this video. Um, because if you cannot do these things, chances are you need to review algebra first to be successful in this class. Okay, please don't pay attention to all this nonsense. The program that I'm using is kind of old and out of date, not supported. I don't know how to take it out anymore. There used to be an option, now it's gone. I don't know what happened, but anyway, don't pay attention to it, okay? So the first problem that we're gonna look at is adding 2/3 and 1/15. So to add two fractions, I'm gonna remind you, you need a common denominator. So, and here, denominators are not the same. We have 3 and we have 15. So before we can add, I'm gonna copy this problem and give me a little more room to work with. So we need to change our denominators to make them the same. So the smallest number that both 3 and 15 go to is 15. 15 goes into 15 once, and 3 goes into 15 5 times. So that's going to be our new denominator. So I need to convert this fraction into something with the new fraction with denominator 15, and I'm going to leave this one as is, right? So it's 1/15. Okay, to change 3 to 15, what do? Multiply by 5, right? Now, the rules of math tell me that if I multiply the denominator, I have to do the same to the numerator. So I multiply 2 by 5 as well. So here I got 15, but on the top I got 10. So the result is now I can add the numerators and keep the denominator. That's the rule of fraction addition, right? Once you got your denominators the same, that's the requirement. That's the first thing you need to worry about. Then you add the numerators and keep the denominator. So we have 11/15, and that's C. Okay, so next, we're dividing. So in this dividing to fractions, and we're gonna review the fraction division and multiplication in this using this one problem. So first of all, fraction division. If we divide by a fraction, what we're gonna do, we're gonna change it to multiplication. How? The rules are you keep the first fraction the same. -7/15. You change the division into multiplication and you flip the other fraction. So you flip -3/7 to -7/3. So you keep the sign the same. If it was negative, it's still negative. It was positive, it's still positive, but you flip the numerator and the denominator. Actually, I'm going to be referring to it a lot, probably, this rule of division by a fraction. Dividing by a number is the same as multiplying by its reciprocal. That's what I'm going to say. And when I say that, this is what I mean. We change the division to multiplication and flip the second fraction, multiplying by a reciprocal. Okay, so now we can actually proceed with multiplication of fractions rule. And multiplication of fractions say that we can multiply the numerators and we can multiply the denominators. So that's how we multiply two fractions. Now, where does the negative go? Well, first of all, negative fraction times a negative fraction is going to give us a positive result. So we could stop there. Or we could bring this negative, by the way, you can bring the negative either to the numerator or to the denominator of the fraction, or leave it in front of the fraction, up to you when you're performing fraction operations. So I'm going to bring both of the negatives to the top. So I'm going to have -7 multiplied by -7 in the numerator. In the denominator, I'm going to have 15 multiplied by 3. And again, -7 times -7 will give me a positive 49/7. And here I'm going to have 45. And the numerator is slightly greater than the denominator, so we have an improper fraction, and we're fine with improper fractions. You don't have to always convert improper fractions into mixed numbers. That is not the requirement. Sometimes it's useful when you're graphing and in some other instances, but most of the time, improper fraction is okay. Now, simplifying fraction is another completely different issue here. So simplifying means making sure that we don't have common factors in the numerator and the denominator, taking out common factors. That you must do. This is not optional. You have to simplify your fractions. But here, the factors of the numerator are 7 and 7. The factors of the denominator are 15 and 3, so which we could actually break down 15 to 3 times 5, so it's going to be 3, 3, and 5. So no common factors. We're good to go. All right, so that was number 2. Number 3, we are raising to the power a product. So inside the parentheses, there is a product. Everything that's inside the parentheses is raised to power 3. So this 3, it applies to a -3 as well as m. So both of these factors are going to be raised to the 3rd power. So basically, raising to the power is the repeated multiplication, right? So it says we multiply -3m by itself 3 times. So you're going to have -3m, -3m, and -3m, which is basically what we wrote here. So -3 is multiplied 3 times, and m is also multiplied 3 times. Okay, so what that gives us is -27m cubed. That's the result. Okay, so be warned. Sometimes what I see students will only like drop the parentheses, says it's -3m cubed. Wrong. This is not the right answer, because this 3 applies to everything inside. It applies to m as well as -3, just like we discussed just now. So avoid this common error. Another common error that I see is number 4. It says -11 squared. Okay, I want you to take a pause here and answer. What do you think is going to be equal to? All right, and I'm going to tell you what I see most of the time. Most of the time, I see that people say that it's 121. Why? Because -11 multiplied by -11 is going to be a positive 121, and that is true. However, notice that there are no parentheses around -11 here. So this square, it only squares 11. It doesn't affect the negative at all, okay? So here we're gonna have that expands into negative, which is not affected by square, and then 11 times 11. So the answer is this negative 121. If we had negative 11 squared like this, where negative 11 is in parentheses, that would mean we multiply negative 11 times negative 11, and that would have resulted in positive 121. So this is another common mistake that I see that I'd like you to avoid. Okay, number 5. We have interesting. We have division, right? Yeah, that's a division. And we have big monomials in both fractions. Okay, so let's see. We're gonna apply the same rule we applied right here. We're gonna turn division into multiplication and divide by multiplied by a reciprocal. So we have 30x to the 9th power here divided by 75. Actually, I feel like I will need more room, so give me a sec. All right, so here it is. I copied my problem, and then I copied the first rational expression times the reciprocal of the second. So I could go ahead and multiply everything and then look for common factors. But that would complicate things for me. I actually like another method first. Simplify before you multiply. This way the numbers are still smaller and it's easier to see common factors. So for example, here, I see that I have 75 on the bottom and the 75 on the top, so I can cancel them out right away. Please remember, when you cancel out factors, you're gonna have ones remaining, okay? They don't disappear, it's not zeros, just in case. Let you know that those are ones that are left behind. Also, note that you can only do it across the multiplication sign. You cannot do it over the addition or subtraction sign, or even division, only multiplication, okay? So what else do we have? Well, we have 11 y's on the bottom and 2 y's on the top. So if one y on the bottom kills one y on the top, and vice versa, or cancels it, so they cancel each other. How many y's do we have left and where? So, well, obviously on the top, we're not gonna have any left, right? Because the denominator wins, it has more y's. So all the y's in the numerator are gone. Now we have one left behind again. So how many y's do we have left on the bottom? Well, 2 are gone, right? So we have 9 left. Okay, let's actually rewrite it, make it clean again. We're not done yet though. So 30x to the 9th over 1 times y to the 9th. And then here on the top, I have 1 left. See, I don't even have to multiply anything anymore. It's all gone. So at 50x cubed on the bottom. Okay, so let's see what else we can cancel out. Well, I have, I see 10 and 10 here. Okay, so 30 is 3 times 10. And 50 is 5 times 10. So I can cancel out 10 and 10. Left was with 3 and 5. Okay, also, look, I have 3 x's on the bottom and 9 on the top. So literally, like x to the 9th means x times x times x times x 9 times. And x to the 3rd means x times x times x 3 times. So when I cancel those out, what am I gonna have? Well, all the x's on the bottom are gonna be gone. And on the top, I'm gonna have 3 less x's, right? Than there used to be. So there will be 6 of them. Okay, so again, let's rewrite, make it clean. So we have 3 left and x to the 6 over y to the 9th, and then times 1 over 5 times, well, everything's gone, right? So it's just 5. All right, so look how much simpler that this looks than what we had at the beginning. Now it's all simplified. We don't have to worry about simplifying afterwards. We can just proceed by multiplying. So we're multiplying 3x to the 6 times 1, and we're multiplying y to the 9th times 5. So in the end, we have 3x to the 6 divided by y to the 9th. That's it. Okay, so that's our answer to that problem. All right, so next problem is on our list. Next problem on our list is the square root of 81. And this is an interesting one. Again, let me copy it. Square root of 81. Well, if I just, here's the thing, guys. If I just ask you, find all square roots of 81, that's a different problem than writing it like this. What do I mean? Square root of, by definition, a square root of 81 is a number that when multiplied by itself gives you 81, right? So, and we have 2 of them. We have 9 and we have -9, right? So 9 times 9 is 81. And also -9 times -9 also is positive 81. So technically 81 has 2 square roots, but this symbol refers to a positive root only, which is called a principal root. So this symbol says out of those 2 roots, choose the positive one. So the correct answer to this is just 9. Okay, got it? So the implications for us, if we are solving a problem like x squared equals 81, and we need to find x, well, then when we unsquare, right? So square root of x squared equals, here we have to write positive or negative root of 81, because just root of 81, it refers to a positive one only. But this problem implies that we can have both. We can have a positive answer and a negative answer. And that's why when we're solving an equation like that, we have to include both. All right, guys. So I'm gonna stop here for this video and I'm gonna continue in the next one.